Thanks for voting on here. So heard of Kaggle and 5 participated. So I'm Mark Landry. So it's a little bit about me and I guess my Kaggle journey. So the Kaggle Grandmaster term didn't even exist when I started. Been doing this for a long time, originally kind of to learn. I'm not even really a data scientist to start. So I started in reporting and data analysis, data warehousing. I think you learned some things from there that maybe helped me. After doing that for maybe 7-8 years, I did kind of start learning more and picking up a little bit of data science and started Kaggle pretty soon. And my very first submission was, as I say often, it was really easy. It was a medical competition. I was doing medical stuff at the time, and I just used SQL to do it. So as a SQL group by statement, produced a CSV, really simple, send it in. I was about middle of the pack. It wasn't very great, but it was like, okay, well, that was easy. Now, if I try, like, what can I do? And so I just kind of got hooked from there. And so there was another medical competition that kind of taught me a lot of things going on at the same point. That was the first one to finish. So, and I got a medal in that one. So that was pretty exciting. I got started pretty quick. I've done quite a lot of them. This is not quite a current screenshot, but it's about the same. So 98 competitions, it's a lot. For a while, I would only do about one at a time. It's about all I could handle. But after a while, you just start to, especially if you don't have much time, you can get in one lightly and kind of define your own goals and things like that. So that's the count of competitions is higher than most. But also the medals there, 8 golds, 30 silvers. So I had one of the most silvers for a while, 19 bronzes, I guess. And the type of competitions, I guess I do well. So this is one of our, I guess, maybe leading into some other stuff. Let me back up a little bit too. So I've been at H2O for about 7.5 years now. It's kind of one of our first Kaggle Grandmaster. That, again, that wasn't even a term at that point. And through some of the people I've met through Kaggle have started bringing some friends and collaborators in, people I met through Kaggle, onto the team here at H2O. And so now I won't claim to have brought everybody in, and it just kind of builds on itself. It's become a fun place to be for people who do this. Early days, Dimitri Larko and I could talk about a customer problem and relate it to a similar Kaggle problem. And then we know a lot about that, and we'll talk about that. So, and I do find, even in general, for those that have just heard of Kaggle, I guess really from the basics, it's a data science competition platform. The nuances have changed over time. There's a lot of different problems. It's very heavy deep learning these days. It wasn't so much in the past, but they're very applicable, I would say, to the work world, because they're very realistic problems. And there's so many now, you can find them. You can find old ones. You can recompete in old ones, see how well you would have done. For me, it's the most fun to compete and just see where you are on a leaderboard. I think it's that gamification effect that hooks many of us that do it a lot and just watching yourself rise on the leaderboard and thinking, what do they know that I don't know? What can I do? And just pouring over it. And the answer's not out there. You can't read the finale while you're doing it. So I think that's why I like to do the active competitions. But what I found when I joined H2O, and maybe even one job earlier, like just answering interview questions and things like that, I had so much more experience by doing Kaggle competitions than you get in the work world traditionally. It's different jobs, different types, of course, but typically you're working on 2 or 3 maybe problems a year, maybe even just 1 for 2 years or something like that. I've been doing the product we're doing now for a long time. And so Kaggle gives you there's a prevalence of problems with all slightly different variations. And as I like to say a lot, is just like, if you open your eyes and you look at what's out there, not just like, okay, now I'm going to do this, now I'm going to try to do the best, but there's a lot of nuance that they put into it as well. Why do they choose their loss metric? Why these data sets? What are they doing with this kind of stuff? Most of the time, you're just trying to solve the problem, but all that extra stuff kind of helps too, because that's where you start relating it to other data sets and other just different machine learning problems that you might experience in the work world. And again, when I joined H2O, I was on a lot of calls with different customers, and I could keep up with the data sets they were at. I just had enough experience just going through problem after problem and understanding data and understanding what you would typically do in these scenarios. So it just gives you a lot of experience, and not just, not long-term experience. You can get that in the work world, but, to spend 2, 3, 4 months on a competition gets you quite a lot. A lot of people don't even spend all that time on it. You jump in the last few weeks and see what you can do. But yeah, it's helpful, I think, for just augmenting the skill sets you learn in any other way. And it's a really great place to practice, to see what algorithms work and which ones don't. There's a lot of things that, the former data science curriculums, or before we even called it data science, would be teaching a lot of methods that you just find don't work very well in Kaggle. So not that Kaggle's everything. It's always competitive. It's generally big data sets. The work world will give you small data sets, and sometimes you need to prioritize explainability. But still, I think what you learn in Kaggle really helps give confidence, so that you can solve those and you can figure out where's the right time to draw back. So that last bullet point sort of, I guess, accidentally sort of alludes to one of the questions that we had up front. So we had one of our panels, Simon, the host of Chai Time Data Science, who's interviewed a lot of us, and he's been at H2O. He's a Grandmaster as well. And he asked, what's your AI superpower? He likes to think of just kind of, you see these ensembles in Kaggle, and we think of this with AutoML as we've got the deep learning, random forest, GVM kind of superheroes doing their own jobs, and they all come together. So there's a superpower theme that he brings to this. So, and this is similar to an answer he gave on some of our Kaggle Grandmaster panels, which we just kind of posted one of those on YouTube in Sydney. What's your superpower, AI superpower? And I think, to me, I said preference, but it's really like my strength is towards competitions that involve twists, creativities, like data sets that are hard to handle, loss metrics that are hard to handle. It's kind of essentially how I met Marios and SRK, by understanding a little better about a loss metric, posting about it through H2O, and got to meet both of them and compete with them many times over, based on something simple like that. And the second part of that, careful consideration of the train test differences. And so this is how I met Arno. So I landed at H2O, actually, was looking at a group-wise split for how your training and test data was given to you. So you're going to be given the whole batch all at one time, but there's no crossover between batches in your training and test set. Very realistic. Most times over time, you might be moving some observations over big sets of things, different products. There's all sorts of ways that this relates in the real world. And so, you use all the experience you learned of a group, but you'll never have one. In that case, the reason that was a group itself was highly correlated. So if you knew this is trying to find various minerals, I think, or metals, something like that. So we're looking at like potassium content, and if you would see high potassium content within a sample of 60, you knew that there was a high likelihood that the rest in that sample were there, but you didn't know in the future, you didn't have any examples from that sample of 60. So you can't use that. You can't leverage that information. You can possibly have algorithms that feed each other. And I'm pretty sure I did part of that, but it was important to understand that you had to not just randomly cross-validate your data, because otherwise, if you can see in that group, the models will learn that, and they will understand that they can push the other ones up. If whatever they see in the training test, they'll focus on it. So I would just encourage people, if you can use the Q&A, feel free to ask anything. So we have a couple of questions that we had up front, so I'll start kind of from some of those, but these are always best if they're engaging. So if you just want to ask some questions, hopefully figure out how to put those in the Q&A. And let me put... And so one of the questions was, in fact, we didn't even get to this on the panel, so I like this question too. So a similar version of it is that, how do you use the Kaggle skills at H2O? How's your Kaggle experience been applied at H2O? And there's many different ways. I think, again, it gives me the confidence to start, but really turning that around, how does Kaggle inform H2O? And, we've put a lot of the Kaggle problem solving tricks into our product. And so that's, I've been a long user of H2O, actually. So since I met Arno back then, I was usually using, I'm more of an R programmer. You have to learn Python these days to run deep learning, but I'm still strongest in R. So I used a lot of R and the R GVM package 10 years ago. That was a good one to use to do well in competitions. And the XGBoost came up right as I was kind of joining H2O. But I got used to the H2O API, and to this day, I still use it. I like the way that you can see everything immediately. You can launch models quickly. Now that came before I was there. So for me, taking the Kaggle experience was to improve our GBM algorithm, actually. And so that's sort of a nice, I guess, harmony there. Going and talking to the CEO and so we've got to catch up to XGBoost. They were doing column sampling mainly. That was one of the big features that we were missing. So we got a chance to modernize our GBM, and later we've included XGBoost, so you can pick both, and I often do. So I'll often do an ensemble of XGBoost and GBM, all written in H2O. So again, even to this day, I just prefer kind of the feedback you get. One nice thing is you can see all your variables, even from the first tree as they build out. And so a lot of these Kaggle winning algorithms in the tree world, eventually will take quite a long time for some of these bigger competitions. You can, I once remember taking my laptop and keeping it open and driving into the office with it and walking into the office and taking a meeting because I just wanted, that thing had been running for like 18 hours and I didn't want to lose it for any reason. So that's rare that you run them that long, except for deep learning. That's actually, I would say, common, but it can happen. So the whole process while you're driving out these trees, think you spend 18 hours and you realize you made a mistake. So, you get to see the loss. You can get a loss curve on some of the other APIs, but, within H2O, I like to see the feature importance because, a common thing that I'll wind up doing is sitting on a problem, like the Kaggle kind of strategy, a common strategy, there's no one way to do it, but, a lot of people prefer to dig into the problem very quickly, get their end-to-end set up. And so going from the data set all the way to a prediction, get a compliant prediction. Doesn't have to be great necessarily, as good as you can manage, but not spending time necessarily trying to optimize the algorithm from the start. Don't plan the whole thing, but just try to get the motions going. You get multiple submissions in Kaggle for those that haven't really seen the dynamics there. Typically the minimum I've ever done is 1 a day. Most commonly it's 5 a day. So you get a lot of shots at it. It's the gamification mode. They're going to give you data you've never seen at the end. So it's all fairly compliant. If you want to let somebody overfit themselves by just continuing to try to optimize that number, you can, but what most people want is a consistent cross-validation scheme, or just validation scheme. Really doesn't have to be necessarily cross, but so that you don't really need Kaggle, so that all your internal results, you should just see them bear out in Kaggle. And so a lot of us, when you get excited about something better, that's the time to submit. Make sure that everything's in very correlated from what you get internally. Your improvement matches leaderboard improvement on there. So that's kind of the setup. And then I guess back to the point of just seeing everything quickly, the setup will be get something started and then try to iterate, ideally as modular as you can, like 1 or 2 ideas at a time. Sometimes it can take a while to build and you don't want to do that. You might throw in 10 or 20 at the same time. But look at where your model's wrong, the residuals, I'll often call them. So look at where it's the most wrong, try to figure out mentally, can you figure out what's going on there? Is there something maybe your model hasn't caught? Can I create a feature to better help it capture those? And so say you do, create something, throw it in your model, and you see that it's no better. And that feature you used is not being used at all. Then you kind of inspect it. Did I mess it up? Does it work? It's essentially a check, a validation that you did something right. So that's one reason I use H2O. So another one, the big obvious one is that a lot of our ideas of the Kaggle winning strategy, I suppose, when we started driverless AI about 5 years ago, are in there. At that time, if you had a good handle on target encoding, you could do really well in Kaggle, and then it just frees you up to think of the problem, I guess, a little more dynamically, and then the models are seeing it in the best feature representation kind of possible. That's maybe a slight overstatement, but that's pretty much what target encoding is all about. And if that's a foreign term to you, it probably is. For many, target encoding, so target being our answer, the why, however you want to think of that, encoding, it's sort of taking all your variables. I use geography a lot into hypothetical ones. So I'm going to take the city, and if I present a machine learning model, 2,000 cities, I've got a few choices. Providing this text generally doesn't work for most things. You've got to convert it to a number. So you can one-hot them, which means you create a column for every one of your 2,000 cities. Or you can do something different. You can rank them. You can do all sorts of different ways of providing it to the model as a number. But one of the cleanest ways to do it, and consistent, it's a technique that just works a lot of time. And this is built into driverless AI, and you can read about in the documentation. There's a good write-ups of a lot of the feature engineering that goes on in there. Always recommend reading that. It's a good idea, just for regular machine learning knowledge. But the target encoding is going to take each city and encode it with a number, which is the average of the target. Depending on your loss metric, you might want to keep it there. Maybe if you're doing median, maybe it's the median target. You can do multiple. It's very common. The max, min, average, standard deviation, common kind of sets. But you got to do it cleanly too. You can't peek into the set that the model is going to use. You've got to show it data. So if I'm going to solve the problem for in Austin area, so Austin, Texas, if the average is 80% because it's 4 out of 5 for that city, it's pretty small, and my target is included in that 4 out of 5, that's not good. So you got to be clean about that, remove it. So maybe I make it 3 out of 4 instead, if that one was going to be a positive. Subtract it from the numerator denominator. There's different strategies about this, and we have some of the best in driverless AI. So that's what the strength of that is, again, picking up that same routine of validation is everything. And so in driverless AI, I really encourage you to bring in a train set, a validation set, and a test set. And we will use the validation set exclusively to do all the feature engineering validation, which features are working, picking the best model, which is a component of the best features, and it drives itself as genetic algorithms. So the validation set is key there, and you want a test set to make sure, even a validation set after we've hit it for multiple models, be clear that maybe you haven't overfit that one so that it still generalizes. So generalizing is sort of everything. A few questions popping in, so been talking a lot about that. So let's see. Yeah, competed on Kaggle several years ago. It had to slow down as I couldn't sleep or woke up thinking of the competition implementation. It's your trick to compartmentalize in Kaggle and did never get to you. Yeah, I guess I think it happens. I guess I can compartmentalize well enough that, when you got to do work, you got to do family, those things are there. But yeah, often it was in the back of my head, even doing some of those kind of things a lot. I remember this time when my wife's parents were in town and just said, I gotta go on the back deck and go work on something for 2 hours. Like I had an idea and I just got to implement it. It's kind of early days. Now it just depends. You got to be realistic about time. That kind of bleeds into some of the other questions in Kaggle. So I don't necessarily have good advice. I think it's good that you're that motivated for it. If I think if I'm lucky, work problems will do that too. And so I guess data science is interesting. Thinking about things is interesting. So for a while it was Kaggle. Maybe the work problems were a little more boring. And so I made a couple of job shifts, I guess. But, now the stuff we do with Document AI now, that's what I'm doing for H2O right now. It's pretty exciting, just, where I do the thinking, that's as likely to come up as anything at Kaggle. But I guess it's also, for me, it's I kind of have to mentally know, I'm in it for this one. I've invested early on, maybe it was one at a time. Now, I'll try one, and if I don't latch onto it in whatever way that can mean, yeah, sometimes maybe you have to give up a little bit. so I hope that helps a little bit, but yeah, it's tough. A lot of us are competition junkies a little bit. 98 competitions. Again, not all of those spending a lot of time on it, but some of them, maybe for 3-4 months, spending quite a lot of time. The panel usually says people treat it almost like a second job. Good question. So existing or new techniques to recommend to create models that are more explainable? Yeah, to non-data scientists. Thank you. You're welcome. But I've to answer first. I'm sorry. Yeah, that can be tough. So there's a spectrum of what explainability means. And so sounds probably crucified saying that, but so first of all, we've put a lot of energy into that in driverless AI. So machine learning interpretability, MLI, is a big component of that. You see that one of the O'Reilly books, I think it is, written by Navdeep Patrick, that's a big thing for H2O. And so there's a lot of, and there's no one way to do it too. So in driverless, you'll notice that we have multiple techniques that are going to help you try to get to explainability. The spectrum sort of thing is, I guess, is that it depends on where that interpretability, who needs to interpret it and how precise they are. And so, for example, it was surprising to me a little bit that even in regulated industries where they do require interpretability, bias is a big deal right now. And the regulators for a long time have been trying to ensure that we're not using bias in our models everywhere we can find it. That's an evolving capability we'll all get in AI as we learn more and more where bias can creep in and our data sets and things like that. But the interpretability is one of those common first steps, is understanding what the model does. I think from a data scientist, even if you're not trying to be understanding the model is still a good idea. And have I put in a feature and am I ready for that feature? Do I think it's going to generalize? I mean, you want to have your techniques set up, train, validation, test. And to be honest, like I often roll them through multiple time windows just to see the stability of that model, like get your architecture set up and then just drop that in and add some data, move it along or expand it either way. So me personally, we've tried to get something like that into some of the tools before. It's kind of tricky. I guess I just do it by hand a little bit, and it doesn't prove the best model. That's not what I'm after. I'm just looking for the stability of my setup, I suppose. So that's, I guess, explainable for me as a data scientist. But if you're trying to deliver something to somebody else, you can take it all the way to simple decision trees. I mean, linear models. People really like linear models. They've got nice coefficients. They're kind of tricky sometimes. You gotta work for your features a little bit to straighten out a U shape into a straight line, things like that, to get optimal performance at least out of a linear model. But when you've done that, you do have explainable features. Some things that we, generally in Kaggle, the more features, the better. That's one of the strengths of GBM, and the GBM flavors, like GBM is kind of the dominant one now, and XGBoost, CatBoost, both common to be used, are GBM, similar class as those. And one of the things that really frees you up to think, and like I said, is you focus on the data and not worry about the algorithm so much, is that you can it's robust to adding a lot of features, collinear features. That drives people crazy. And if you're in the linear world, it should drive you crazy. But the trees just keep firing things in. So a common Kaggle technique would be get a hold of some good variables, study them, figure out where they are, and then actually just try some things out, try interactions, try putting some features together. And what that sort of means is you're going from big features with lots of support, I suppose, lots of observations, and you're going to make them smaller and smaller and smaller. Every time you interact things, it's going to be fewer and fewer of those. And if you compound this with target encoding, you get a whole bunch of collinear features, and it's okay. You just learn to be okay with that. But then when you turn around and try to deliver something explainable, maybe you're not okay with 1,000 features, 200 of which look almost identical to each other. So lots of different techniques. I definitely recommend, driverless is going to do that with a decision tree. We've got, Shapley values are a really common one to understand things. Like feature importance understands where your model's at, what's driving your model. And, sometimes you have to take a hit in accuracy a little bit to get that. So if I have a model with 1,000 features, can I crunch that down to 20 and get within 1% of the answer? And that sounds like a small percent, but that's actually very possible sometimes, because that last 1% is what happens in the rest of those features in a big statistical model that's going to just run thousands of trees. But maybe you're better off with that 20 features, or as small as you can reasonably get it, and kind of the accuracy trade-off with the complexity. So I guess for me, because I like to, as I said, like start as an analyst, I think of myself as a problem solver that knows how to do the machine learning side well enough to get decent results. But so I tend to over-analyze the features, and over is correct. Like, it's not the best way to do it. But that maybe serves me well when it comes time to go and explain things, because if you can understand what's driving your models, I typically will poke at those a lot of ways with some really simple techniques. Just EDA actually is another good thing, exploratory data analysis. That I have no common recipe myself for doing that, but just understanding that data set as well as you can. There's some data sets that are beyond my comprehension. So, there's no free lunch rates. There's no one way to do it. But but going through things and exploring whatever those features are and understanding what is it about that. Either I get it, okay, I expected that because I knew that intuitively, that's how I would solve the problem, just guessing without data, essentially. And then just kind of bridging that understanding to where the model is. And so there's a lot of ways to do it. I've done this over a long time, and arguably again, you could say it's even like 10 years prior, because that's a lot of what you're doing with creating reports for things. It can be a simple job as intelligence and stuff like that. But those are your common features. Like a top 10 is not a bad idea for understanding what your model is doing, things like that. So can you share that one I might not take it up front, but in what aspect do you learn more in H2O than Kaggle? And what aspect do you learn more in Kaggle than H2O? Yeah, I think H2O, fortunately, because of the situation we're in, we do get, it comes and goes as everything, but we do get to hear a lot of customer problems. So I think for typical people, I guess in my prior roles, that had been a bit of a struggle. All the data's out there, but you don't have time to go like work out a project and really struggle at it. I think again, like, thinking of something can be done, but really trying to execute it and trying to figure out how that works. It's framing a business problem. There's a lot of things that, maybe that's a good way to let me pay attention. There's probably a lot of answers to this question. Where do you learn more in H2O than Kaggle? And this, I could probably say, the business side of the problem. Kaggle's handled all that for you. Like I said, open your eyes, pay attention to what they've done, because that's what you need to know. You're on your own doing that when it's your turn to do it in the work world. So Kaggle's prepared data. They've thought of a problem that ideally makes sense. It's worth solving. They've picked a loss metric that helps them guide towards what good results are. In deep learning, some of these are, the metrics still are interesting in how you optimize things. So you'll see some of the math around optimization on some of these can be useful and gain you 10, 20, 100 spots. You look at, there's some people are very good at that aspect. And that's good for winning Kaggle problems. It's relevant for the work world. It may not always be good for the work world because if you're exploiting a metric versus optimizing it, there can be a slight difference. On that, have I picked the right metric for the problem? But a good example I would have is when I was at Dell, we were doing a problem that I just threw a GBM on something and just started working on the problem, thinking it out. And after a couple of days, I realized that it was surprisingly not better than what a model that had been in production that was not barely a model. It was a very small statistical model. And we assumed that we'd have a lot more data, we could do a better job of fitting that. But it wasn't true until I handled the problem correctly, switching RMSE as the loss metric to MAE. And actually we wound up doing quantiles with that. We wound up doing a few. And so that was the right way to frame the problem. And that was something some Kaggle problems had been exploring MAE, and some people get all upset about it because it's hard to optimize. And not all algorithms can handle MAE, the H2O ones can't. So, but it's tricky for calculus on that. So, but you can get upset about it, or you can learn from that and understand what it is. Why are they using that? Why does this make sense? When might I use that? And so still, as I just said, it took me a couple of days to realize that, and I was just setting stuff up. But when I did, that was the way we made progress on the problem, because the incumbent solution took that into account correctly. So we were able to beat it at some point. But framing the business problem and everything about it all the way to the future, so we can solve this. Is accuracy everything? The accuracy that matters is what your business problem needs to do. And that may not be the way you can actually optimize your machine learning algorithm. Ideally, and I see this a lot with the other Kaggle Grandmasters that we have on the team, hearing them answer questions with customers, that I learn as well, seeing their frame of mind rather than just the solution here, the thought process in the middle of it. And where do they go to first? That's one bit I can learn at H2O. I have learned at H2O, just exploring the different personalities and how other people think, and the repetition you find out of that. Sometimes it surprises you, but really paying attention to what's going to make this business problem successful, which may not be the same thing. What I was going to say, you want to align that as closely as possible, but sometimes you don't have a choice. You just can't solve the problem that way. It's a multitude of different things that all have to work in harmony. So for more in Kaggle than H2O, I think, I guess you can look at maybe to some extent hydrogen torch, and like that's where we sort of sharpen our tools and see things used first, maybe. Occasionally we may innovate something at H2O, but a lot of times we pay attention to Kaggle and see that the sharing in Kaggle is wonderful. It's just gotten better and better over time, to where it's a different Kaggle than it used to be, I would say, because everyone can copy the good solutions now. And some people are probably fooling themselves thinking they can do that. And then you get out into the work world and you realize, whoa, I was able to immediately stand on the shoulders of the people who were solving that problem well. And I just got a free pass through that section. older Kaggle, it wasn't the case. The sharing wasn't there, so there's a little to take from both sides. But where we learn, it shows, particularly in Hydrogen Torch, that team, when they see something innovative come out, they work to get that in the tool in the next release, or pretty much as soon as they can. So they can see, you get to see a lot of different problem attempts in Kaggle as well. What works, what doesn't. You can see, the papers that are produced in deep learning are great now, and a lot of those do work well in Kaggle competitions, but not everything in the research world that comes out will work well on Kaggle. So it's a little bit of seeing where the rubber meets the road, to a certain expression on that one. So. It's a Kaggle question. Recommended process for model retraining, specifically figure out whether to include older sample data, use only new data. Yeah, I guess, well, this is why I guess I say, maybe I hinted at this in a little answer, like I provide, even if time isn't necessarily a consideration for your normal train test split, yeah, I mean, from my sense, doesn't really apply to this answer, but think time first and only prove to yourself that you can do something else. Now, there's a lot that are. If you're just taking images from the wild, images this year are not going to be, largely different from images last year and images the year before. But, we're typically not deploying solutions against yesterday's data. Sometimes you do, but most often it needs to work in the wild in the future, and you want something to be robust. And so that's why time should always be, your first thought of how to split something. That's not to say you approach it as a time series problem, just consider time. And so that's, I guess for me, again, these like rolling validations, it's just something really common. I'll set up, like, just chunk my data out for 12 months and then test on the 13th or whatever makes sense for that window, whatever I'm worrying about. And I want stability. And I know that those models will not be as strong. People don't like this in competitions because it makes time makes the test set, gives it a higher variance. So if you have random cross-validation, you're much more likely, just not knowing anything else about the data, you're much more likely to say that my training score, and in Kaggle, this is my public leaderboard score, is going to correlate really well with my private leaderboard score. The further you move away from random, the less likely that is, generally speaking. But there's plenty of ways of controlling for that correctly. Some that are out of your control. So just in a really basic sense, if I'm doing something that's not necessarily time series, but I'm working with products, companies change their products all the time. And so if I know really well who's going to be interested in this product that was alive, for the last 5 years, but we sunset it and we're bringing a new product, you would think that would say, well, all that learning is gone. Intuitively, that's what I always thought. Well, I don't want my model like just trying to grind away and use all of its capacity to learn, spending it on something that I'm not going to have in the future. But if anything, in Kaggle, I've found that it's not that simple. Sometimes the models can actually learn stuff from historical sense that do serve you well in the future. So it's just let the model and the scores, tell the story there. Don't quite like throw that away just yet, even if intuitively, even to this day, it's an awkward kind of thing for me. But it tends to be true. So getting your infrastructure set up. So for model retraining, it's kind of like, ideally you'd have thought of model retraining even before that. Like, let me think of how this thing's going to work. Now, not everyone has the luxury of enough time that you're going to have a big data set. I mean, that's tricky no matter what, and there's no good solution to that. You just need more data. It's always easy to say, hard to do. But if you have 500,000 rows across 3 months and you need to extend to the next 4 months, that's a hard thing to give up on one of those months. Well, if you have 500,000, I guess you can. But either way, there's some kind of trade-offs there where it feels like you just can't give up on some of that data. And in fact, this is there are other competitions within Kaggle out there. I like to do those too, Analytics Video in particular, but Crowd Analytics, Zindi, or a couple of the other ones. Driven Data is a really good one. There's a lot of other platforms out there doing different things, but one of them, two of them, I've had to write messages to the organizers that you've got to split this more correctly. You're letting everyone use bad practices to get out there, and they're doing random cross-validation, and the solution is going to produce was useless. You could overfit certain things that you would there's no way you would know that when you deploy it. So those are the things you want to think about as a data scientist. And I guess on the process for model retraining, the more you can think of that ahead of time, not of training, like of doing that, is that's I do that a lot. I'm like really curious how things are going to work in the future, studying that of the features, how well. So like one of the things I like to do, I don't do it all the time, but is to take a data set where you and look at the one-dimensional accuracy of using the best way of encoding that into an average model, like a target encoded model, really. So a mean model, however you want to think of it. So I'm going to go through all my features again. Let's use the city example. So if I split my data, again, like if I can by time, but in any way, if I split my data, or I've got a training set, and I fit a model that gets the average of every city and predicts that as the model. If I'm doing RMSE, that's a reasonable way to do it. And you test on the new stuff and just see how well that one-dimensional thing works. Like, what's my AUC doing that? Maybe it's 0.87 already, pretty good. So I just like to know that. It's always going to get better if you use a machine learning model. I've never seen that ever win out. But you get simplicity, you get to feel how powerful those features are before they get to the final accuracy. And sometimes you can get excited about a 0.87. You merge that with some other dimension, the age of a user or something like that, all of a sudden you're at 0.91, but then a machine learning model is like 0.985 at the end. At least you know what those gaps are. But where this ties into the question is seeing that move over time also. So how does my city, if I have enough of this data, if I train my city in the same way, single one-dimensional model, and add 2, 3 is usually what I like to do, is just kind of loop through those if you can. Let the computer do its thing and just observe a ranked order of what are my most predictive features directly on the problem I got to solve. Not correlation with the target, not other just different statistics that do it. The actual metric, you can do that. So seeing where that goes and how stable is that over time. So measuring it over a window and watching it go from, what I say, 8.7, but maybe the next period is 8.2, like it's bouncing around a lot. That's another part to be aware of. And that'll point you to where you may not have stability, and then looking ahead at retraining or promoting that. What are you going to do about it? Are you okay with that? Sometimes you have to be. There's sometimes just no other choice. So, okay, it's unstable, but that's all I've got to work with. So I guess that's one answer. But yeah, that one's definitely speaking to a lot of my preferred processes, working through a lot of these, a lot of problems. So what things cannot be learned on Kaggle are useful, should be learned by data scientists from industry point of view. All the way on like communicate. There's lots of skills here and lots of different company roles too. So there's no one answer to anything. I've been saying that like 3-4 times now. But so where I mean that here is that we work with some companies big enough that they have modelers that get to mostly spend most of their day modeling. And I think some of the Kagglers, like, that's what you want. That's your dream job sometimes. But other places, you're at a small startup that's exciting. It's a new problem, but you're the data scientist and a data engineer and some other things. Or even if you have a team of data scientists, sometimes you wind up spending your time on other parts of the problem. So a lot of that is Kaggle's not necessarily teach it to you. Again, keep your eyes open. Maybe you can learn a little bit about it, but they're not really going to tell you. You just have to kind of guess it. And that's, I guess, what I find myself doing a lot. Why would they do this? Sometimes they may have not done it for any good reason, but I'm going to still think through. It's an interesting thought exercise, I guess, of why it's there. But I would find this at a lot of competitions, they draw this nice write-up that seems interesting, and then you look at the problem they're solving, it's like not quite as pristine as that. Even just finding the discrepancies between that, because that's what they're going to be asking you in the work world. So software engineering would be another side of it, I guess. I think that with Kaggle's code competitions, that pushes the level of difficulty up. And unfortunately, it sort of spoils my old answer of that very first Kaggle submission being simple, and Kaggle's just a CSV. It isn't always anymore. That's for good reason. It's unfortunate, but it means you do have to be at least thinking in slight software engineering terms to get a model executed. I mean, you've got notebooks, people helping you through this process for sure, but that's not just you can get away with not doing good software engineering and be good in Kaggle. I'm not a great software engineer myself, but when efficiency matters, knowing that and looking for it, again, I'm not that great, so Kaggle doesn't teach it to me. I picked it up, I've observed what other people do, but there's just so many, people that can do such a better job than me at those things. But there's a lot of the software engineering side. So that's efficient, elegant, good coding that you typically associate with software engineers, but it's further than that. CI/CD pipelines. In the work world, this stuff matters. And like that previous question was good about model retraining. That's, you've got a model live and you're going to retrain it. So what are your processes around that? The ML ops world, that's a term now for the last several years. Deploying it, have a model repositories, all this stuff, like the engineering side of it, or just, it's becoming more mature, that there's ways of doing these things, and we've got nouns that we didn't have 5 years ago. So a lot of those are not relevant in Kaggle. That's nice. It kind of pares down everything to problem solving and putting the best algorithm to win. In a code competition, you do have to get it running at a certain time. So, and then sometimes you have big problems. You'll see half the field will go out on the first rescore of some of these code competitions. I've seen that a couple of times, where people blow up their memory limits because they didn't project where the data was, even though Kaggle was trying to tell you where it is. So some of these things maybe you can learn, but it's I'm not sure the recommended path on how you'd find those things. But the nice thing about joining Kaggle is I know the ones I just spoke about because I was part of them. I'm sure it's happened on many, many, many more. But the ones where you're part of it, and hey, there were 1,000 people here. Why are there only 400 left? The 600 of those people had their notebook blow up. But I guess a lot of that, it can feel like a slog a little bit, doing it in the work world, but that's one of the things maybe I would gravitate towards. And then I started with this too. You just can never say enough about in those roles that involve communication, which is most, but not all. Communication is always a good skill of understanding, trying to get at the person you're working with who has the problem, the business usually, and figure out what's really driving that. And if you solve that problem, will it be good enough? Sometimes you meet halfway, and that can be dangerous because they've given in on what they really need, and you're trusting that they're giving in was correct. Because I've seen this several times where you solve the problem you had disagreement on, and it turns out that wasn't good enough. Actually, well, this accuracy, fine, you've got this 90%, but we're still missing all this stuff. Well, so, we agreed to move that out of scope. Well, I can't have that out of scope. Things like that. Typical kind of project management, software engineering. So those are big, giant domains, books and books written about these things. But I guess I would say more data scientists than not, one or both of those two things are very important, and you can get away not being good at those, I would say, in Kaggle. So, I think anybody could achieve a master grandmaster tier on Kaggle with enough time and effort. The creativity that grandmaster have can be learned. It's tough to say. I think a lot of us like to think yes. I'm not sure about that. Maybe just speak for myself. So I guess long I've thought yes, with could you train somebody? Could you have them working through the same things? But eventually that creativity seeps out in the training. Can you just let somebody loose and go after these problems? No. But with the right guidance, maybe, I suppose. I think it's a set of stuff. It's just how brains learn, how all of that is important. So it's not always about creativity. So I think, again, my weak spot. So I prefer that. So maybe I've kind of elaborated on that a little more. That's the way I like to solve these problems, is to think them through mentally and solve them, look for creativity and elegance, look for that golden feature, but lose sight of, if I had spent some of that time or all that time working on 100 features, I would have found 3 or 4 that worked about as well as the one, plus I never found it. And that happens a lot. So that's teams, I suppose I've learned a lot from as well on Kaggle. I would say it's a lot, Brandon and SRK, my most common teammates, they both have an aspect that I don't have, and I can't catch up to it. I know what they're doing, and I'm sure I've gotten better at that, but that's what they kind of do. Like they're both of them, and they're both great at thinking of things and being clever as well. But the thing they definitely do better than I is that aspect of, when you have a good idea, don't just do it there. Like engineer. The engineering side of feature engineering is roll that out to everything. Don't be scared of volume and things like that, even if it takes a little while to run. And I typically do work one at a time a little more, so small-minded. But so I have things to learn. Not everyone does, I'm sure. But I think a few of the things, like I talked about, when I see people do it wrong, even if they invest a lot of time in it, but they kind of dismiss maybe the tough lessons to generalize that. They're going to make excuses for why they didn't do well. Oh, I would have got that if just this or that, but you didn't. You know, that's one of the things. Like facing the reality of a competition leaderboard is a good thing for internally. If you can internalize that the right way. I mean, well, there's no right way, as I keep saying, but I think I learned a lot from that. Like looking at early on. I don't even do this much anymore. Occasionally, I'll pull up a few solutions, but when learning the most aggressively on Kaggle, every time the competition finishes, you would find write-ups from half of the people that beat you. You know, half of the top 10 would write one, or maybe sometimes almost all of them. And if you read them, it's often a mix of subtle things and some clever things that it's like, oh, I would have not gotten that, or I can learn from that. Maybe I can try to get that next time. But sometimes you look at it as like, boy, I really thought I would have had that, but I didn't. They got it because they went one step further or just did one step different. And so, I guess the right combination of trying to view Kaggle from an educational standpoint and also trying to do well on it, because the two reinforce each other, I guess I would say, and looking for it and always trying to learn. You find, our super GMs, those that have been, first, my peak rank there is 33. And, Grandmaster, we have people that have been #1, and that's a whole different thing. And even they will pick problems that they want to learn from, like Philip and Dimitri, that was kind of their way of choosing new problems that were doing different things for them. Sometimes they were intrigued to solve something different. They've said that before. So, even the people that you think that, nobody knows everything, but some of them feel like they know more than others, they still seek to learn a lot of times. I think, if anything, like probably my own progression is probably cut off a little bit because I haven't done that as much mentally. So, can anybody still? I guess it's a prediction. So, large majority, if you put the right time in and can land on some good ways of doing it, things that work for you, work on progress. I don't have that training regimen, can't give it here, but I think a lot of people probably could. But is there still something different? I guess there's some people that just don't think in data. I guess I've run into some of those people, and I maybe failed to acknowledge that for a while. So for me, like, I just think naturally in terms of spreadsheets, practically data tables, things like that. I'm just looking at them all the time. Just my mind is geared towards that a little bit. So I'm sure that helps me in ways that other people have to overcome or gain that or whatever in similar ways for me too. So I would certainly, I guess that over half of people, as long as you're motivated to keep doing it, I suppose I would say that the Grandmaster title can be, if you learn enough to join teams, you learn from teams, and teams help you get gold medals. There's no denying that. But you got to do solos. That's the Grandmaster title. You did list Master Tier in there as well. Master Tier, I forget exactly what it is, but I know when I got the Master Tier, that was the only thing that existed. Yeah, I know where I was exactly at that moment when that leaderboard turned over. It was so exciting. And I was so close from so many competitions before that, 12th and a lot, 15th, and then finally got the third. It was the second one, the BCI challenge. And yeah, I think, just plugging away and learning and trying to always improve. I do think that probably anybody with enough motivation to stick with it probably can earn a Master Tier, but you got to just be not cut off to learning and always trying to improve. If it's a little harder to get started, then acknowledge that and just keep trying to find your own goals. Some techniques rank feature importance in relative order, but the features may not really be important compared to continuous random, discrete random. Question: besides permutation feature importance, would you recommend other techniques for identifying features truly important? Yeah, that's tricky because so again, the rank feature importance is a good one. However, we're using GBM models or trees. You like random forest better or something on a lot of the tabular. And to acknowledge this at least, like deep learning is coming, and at some point, deep learning will take the tabular world over. But as of now, it hasn't. And you can look. I don't think at this point there's any better way to prove that in Kaggle you can still do well with like GBM models. So framing them in deep learning frameworks as transformers takes off, and then the new architectures will eventually probably get to where deep learning can take these over, but it isn't now. So then when you're using those tree models, feature importance still really helps. And so it's definitely a great tool to start out, like what's going on with my model. But you have to also be aware, like I said, we're not scared of collinear features. But that's not to say that the tree models are going to agree with you with their feature importance, because that kind of means that they can pick and choose either one for most of the problems. So if collinear features means, or let's say I do the city one again, I'm going to have a target encoding of the city, all the cities in my data set as a feature. And then I've seen that that's a good one. So I'm going to just grind away at that. So I'm not going to interact city with the age, gender, as I said before, or just age and age, gender, things, whatever's in your data set, your common kind of features, interact those and keep digging deeper and deeper. And you'll probably see those feature importances lift up, but it'll smooth the whole thing out a little bit. And your previously good feature, the actual one doing the work is the city encoding, but the interaction of it is with something else. So I think just going after it, and I guess the MLI side of it, understanding what's making up that model. In the tree world, you don't have to cut the last features either, and I'm not a fan of that necessarily. So, if you have 1,000 features, a common one, we could take all the ones that score 0, and throw them out. And it's amazing sometimes how well your model will get worse. Now, in the work world, if explainability matters to you, almost even at all, then you're probably fine taking that tiny hit to the 5th decimal. So Kaggle, we're competing on decimal places many times. That's why it's so impressive when you see the first place person is a huge way away, or the top few have broken away from the pack. So that happens too. But wherever you are in the leaderboard, you're going for big gains, but chances are you're going to get small gains most of the time on your way there. So in Kaggle, that last decimal place can matter. And maybe still have an intuitive idea of what your model's doing and where the features are, and ideas you don't explore. So I guess for my process, I mean, it's not going to be a great answer to this one, but it's just certainly my own answer. But some of the favorite things I have with working with teammates is just listing ideas that you can do and slowly over time executing those. And that's no different from normal project management, particularly product management. What do we want this product to do? Let's make sure I get the basics cut in your first release, but then add the features we've always wanted. And sometimes you realize you don't need that feature later on. I think the same thing's true of these data sets. And so, getting the basics in order, getting a model that you like that performs where you think it's right, that's harder when you don't have Kaggle, everyone else competing at you. They tell you what right and wrong is to some extent, but to a large extent. In the work world, you don't really have that other challenger model to push you. And so you might have thought 0.81 F1 is great, and if you had realized it, 9.1 was achievable. Some of those things can happen, but that intuitive sense of the model. So getting the basics up and running, and maybe it's throwing all the features in there. I mean, my own approach differs. I guess that with that one-dimensional kind of method that I was talking about, I'll usually have both. I've got a GBM that's set on probably all the features, to be honest, and then my little target encodings that are working towards that. And at some point, I take the best of those, and that informs me what to focus on, how to get more value out of it. So I would say that for, I guess, the features that are important, I mean, with trees, you're not too concerned about that. So continuous random, discrete random, to be honest, I don't pay attention to that. So the trees don't care. It's a little better to get them shaped in order if you can. So, but that's what you focus on. So I guess so I say I don't care about it, it's not really true. It's just don't care about the specific terms. I trust my models are going to cut that distribution up really well. I don't have to straighten out that U-shaped curve like I would in a linear model. They're going to cut it to pieces, and eventually they're going to make those straight lines. Eventually, we can trust that our XGBoost like GBM models will do that, as they generally do. And generally, you can fairly reliably, not 100, but 99 point something % of the time, they will straighten those features out if they're important. So I would trust them to find the models. That's the first part, maybe, I suppose. But then with feature engineering, there's a better way to represent them. And so that's really where it is. So I guess, again, there's still no right answer for anything, but you can look at your residuals to find the ones that are performing worst and try to figure out, what is it about these that I can do? Is there a better representation of those features that are driving this? And if you can get your head around it and realize what it is, then that comes pretty quickly. Sometimes you can't just look at the data and I have no idea. I'll predict 92%. That seems like a good idea, but the answer was false. If you can get your head around it, or you understand the way the features are, or you can throw a less useful model, again, if I can work my way up, I don't always do this, but what did my simpler model do for the same thing, and what's the difference, and is this model a fit? Usually they're not, though. So my particular strategy is not necessarily to worry about it overfitting in that way. It's probably something I just haven't shown it correctly. This came up in one of the talks, but you know, what can all these GBM models are using decision trees underneath. You can use anything, and occasionally you can set a GBM next to linear model. But typically, the reason decision trees, what decision trees do, they're really simple. It's just left and right. So, if it's a category, well, there's different ways you can handle categoricals, group-wise split or not, but they're going to send a bunch of values, or particularly just one. The common implementation, just one value is left, everything else goes right. Numerics are nicer and neater to chop up. Find that best point that optimizes sending my data left and right. We do this with validation sets all the time, so it's cleaner than it might sound. Decision trees will do that and they're done, but GBMs essentially just keeps doing it over and over, oscillating the features and the rows. And so, but really you have a really simple tool at the end of the day. It's pick a value, everything below it goes this way, everything above it and equal goes right, or wherever the equal goes. But it's a good recipe for doing that. But what it means is sometimes you can't see things, and your model cannot necessarily put two features together. Yes, the decision tree can split on feature A and send the low parts left and the hard parts right. And then within that low part, split on feature B. What they can't see is both of those at the same time. They only see a huge mass of observations at one time. And so sometimes it's nice to show something, they also can't see across their rows. That's more of the thing, like the features, but they can't see across rows. And so if the concept about a customer is the number of times that customer has shown up, the model does not know that. It doesn't know it. It'll try to memorize the customer number if you've given it information and find the features that describe the customer. But what the model does not know is that that's a common customer. So that's a common, and again, going back to driverless, that's a really common feature that we like to put in there. So it's not necessarily, it's a mix of everything, I guess, but thinking of the best way of shaping these variables, usually for me, is trying to think of what can the model not see, because I'm mostly going to trust it, even if it's not perfect. It's close enough, and I guess me bang for the buck, where I'm going to spend my time is not necessarily going to be to constantly tweak the way that I'm showing a feature to it, unless I think it can't see it, and that's a vague concept. But if you think in decision tree world, what can it not see? How does this algorithm work? That's what it is, which is why, again, just counting stuff like categoricals, counting them, getting these averages, getting things that can't see across rows. Otherwise, its way of fitting it is just to send everything left and right. So the more you can see what you think of predictive features of this, common customers, things we might describe in human terms, it's trying to get those in there. So I guess that doesn't really speak to feature importance, but I guess that's where I spend my time on there. I do mostly trust the feature importance, but I will commonly look through there, mostly just, again, for that same idea of testing something. So throwing something in there, seeing if it's useful. And if it isn't, why? Is it already, and there's two answers to that, at least. One, because I messed it up. I messed up my own feature. Let me go back and see, did that work like it was supposed to? It hasn't helped the model. So that's a good sense check. But also, maybe it's covered in all of my other features. The model's actually found it through 4 or 5 features. And at this part, we're getting close to time. So, some of these techniques I have will start to lead you. These models are powerful enough you can overfit those features. And so sometimes I would like to handcraft this nice blend of 5 features into one feature, and that's super powerful. And it's super easy. It's easier to explain. It seems to make more sense. And so you can roll all that stuff I've been talking about for a long time, the city and how many times we've seen that customer, common customers get their own bucket. We're going to average that. That's pretty self-explanatory when you have it. But the models generally perform better if you let them break it out. They'll usually learn faster if you show them big, heavy features where all the thought has been baked into one feature. They're going to love that feature probably. But at some point, it's just one feature, and they're more robust to fit it. And you've put some of your own assumptions into that feature of how you blended it, and if they can see it more natural. So that's a tough pill to swallow sometimes, that you put all this work into something and it helps you for a while, but at some point you almost have to back off and let it find everything. And I don't know, that's an art form probably, or there's probably science to that, but I don't know But I've just seen that time and time again. It's usually the clearest way to see it is because you've let the model, it's already found it with 4 or 5 features. So much as I tell the tale as if, eventually you're going to want to back off, but usually it's more that got 2 competing models, and why is my super feature like not helping here? That model's not as accurate. I got to take the super feature away sometimes. So that's a little tricky. So sorry I talked so much on some of these questions. I definitely haven't quite gotten to all of those, and we are at the end of time. So ideally we can set some of these, find me on LinkedIn or something if you want to ask some of these. We'll maybe find a way to get some of these questions answered. We'll also do more of these ideally, so hopefully we'll get some set up in the new year and can ask some of these. I'm a more tabular approach. You'll find a lot of the people at H2O right now are great at deep learning. Some of my good finishes are in deep learning too. I've got a long way to learn on there, but Kaggle helps me do it, and the other platforms, even Zindi, crowd analytics, is a fun place to get going without the pressure so much. It isn't there, but mentally it's still the truth of why I do that sometimes. It's a little more fun to get around a problem around Zindi and just try to do a good job with it, and learn what you're doing, and still kind of a beginner, intermediate kind of level, and leveling up. And then Kaggle, people will gravitate towards like a good solution. You can copy that, take that, branch that, and optimize little bits, and you learn from both sides, I think. So with that, thanks for some great questions. Thanks for hanging on here, and hopefully we'll see you on another one.